Welcome to Factoring Polynomials. You might think that this is really boring, but it's not. There are many real-life applications for factoring polynomials, one of them being finding out the dimensions of the ice curve if you're an ice carver. Factoring polynomials may seem hard, but when you use the remainder theorem, it's not. The remainder theorem is when a polynomial p times x is divided by x minus b, and the remainder is pb. Michelle here will help me explain.
Hi everyone! So what Sarah said may seem a little bit confusing, but when we put it in an equation, it's a lot simpler. So we have our polynomial, px. It's divided by x minus b. When we use our steps of long division, which we will explain, you get a remainder of p times b.
To make the remainder theorem easier to explain, we're going to do an example for you. So we are going to have 2x cubed minus 4x squared minus 7x plus 1, all divided by x minus 3. Yep.
This is an example of long division using the remainder theorem. So we do 2x cubed divided by x, which would give us 2x squared. We times 2x squared by x, which would give us 2x cubed again. Then we do 2x squared times negative 3, which is negative 6x squared. And then we subtract these numbers. That gives us a 0, and this gives us a positive 2x squared. And then we do it again. We do 2x squared divided by x, which will give us 2x. Then we times 2x by the x again, which will give us 2x squared. And we drop this negative 7, and we times 2x by negative 3, which will give us negative 6x. And we subtract them, so this is 0, and this is negative 1x. We drop the positive 1, we divide negative 1x by x, which will give us negative 1. Negative 1 times x gives us negative 1x. Negative 1 times negative 3 gives us positive 3. And then we end up with 0 and negative 2. So that gives us a remainder of negative 2.
But Sarah, that seems awfully hard. Now, there's an easier way to do this, and also a way to check if your remainder is correct. We use our remainder theorem of x minus b divided by px equals pb. We can do this by making x equal b and plugging in b for px. Therefore, we have pb. So for this equation, it would be x minus 3 equals x equals 3. So we would take our px, which is 2x cubed minus 4x squared minus 7x plus 1. And for every single x, we would plug in the number 3. So we would have 2 times 3 cubed minus 4 times 3 squared minus 7 times 3 plus 1. Now when we plug all of that into our calculator, we get a remainder of negative 2.
Okay, so this looks like it would be an easy long division problem for when we used our factor theorem and we got our pb over a, but we can't do it because here we have an x cubed, and this we just have an x to the power of 1 right there. And so to fix that, we would write it as 6x cubed, and then we would just stick a 0 x squared inside it, and then just write it out like it was. So then now we can do it because now we're just going in order of the numbers.
Okay, now we're going to do the factor theorem, and there's two different ways we can do this. So the first way, we're going to do p times b over a divided by ax minus b, where a is a factor of the first term and b is a factor of the last term. And you're going to end up with a remainder of 0. But this is when a does not equal 1. Or the second way is when we do PB divided by x minus b, where b is a factor of the last term and a is just the 1 here in front of the x.
Whoa,
And you're going to end up with the remainder of 0, and this is when a is equal to 1.
Our example for the factory theorem is going to be 6x cubed minus 25x squared plus 2x plus 8. Now, since our a value does not equal 1, we're going to have to use the equation ax minus b divided by pb over a. Now, our possible b values are all factors of 8. So that's going to be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Now, our possible a values from 6 are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now what we do is we match up our b and our a values for all possible combinations of b over a. We already have calculated by putting in negative 1 over 2 into our equation. So for every x value, we plug in negative 1 over 2, and we get a remainder of 0. So now we do our steps of long division to figure out the quadratic.
Okay, so now to fully factor equation, we first need to do long division. And so this number that's out front is what we got when we did our factory theorem with p is b over a.
Is it good? Okay. So you may notice that up here our quadratic isn't fully factored, so what we're going to do is factor by grouping. So we have our quadratic down here, and for factor by grouping we need to find a number two numbers that add to the middle term and multiply to the last term. But since our a value does not equal 0, we have to find a number that multiplies to 3 times 8, which is 24. So adds to negative 14 and multiplies to 24. Those two numbers are negative 12 and negative 2. So what we're going to do is plug in those numbers for our 14x. So we get 3x squared minus 12x minus 2x plus 8. Split this down the middle to do our factor by grouping, and take the biggest number we can out of our first term, which is a 3x. Left in the brackets, we have x minus 4. We do the same with the other side. We get a negative 2 up front and an x minus 4 in the brackets. Put these together and we get 3x minus 2, x minus 4, and 2x plus 1, which comes from our beginning. Now we find the x value for each of these. So it's going to be x equals 2 over 3, x equals 4, and x equals negative 1 over 2. And we're all done. So now we're going to walk you through another factor by grouping, but this is where a does equal 1, so it's a little bit simpler. All we have to do is find a number that adds to the middle term and multiplies to the last term. So that would be plus 5x and plus 2x and plus 10. We split it down the middle, factor out our x here, and then we get x plus 5. And then we factor out a 2 here. So we have 2, and then x plus 5, and your factors are x plus 2 and x plus 5, where x equals negative 2 and x equals negative 5. Factoring is factoring a perfect square, where we have to find a number that adds to our middle term, which would just be 0, and it multiplies to our last term, which is negative 16. So the two numbers that add to multiply to negative 16 would be positive 4 and negative 4. So we have x plus 4 and x minus 4. And to check if you're correct, you can just use our factoring technique we're going to show you is when we don't have an end of term here. So all we have to do is take out the greatest common factor, which in this case would be a 3x. And then inside the brackets we're left with 2x plus 1.
So now you know everything you need to know about factoring polynomials.